Okay, so thanks, Maria, and thank you everybody for being here. Now we are moving to it's the second contributed talk of today. Right now, we will have the pleasure of listening to Moisés Macías Bustos from University of Massachusetts Amherst and María del Rosario Martínez-Ordaz from Federal University of Rio de Janeiro, whose talk is titled on why to be a structural realist about chemistry. So Moises and Maria, you have 20 minutes for your presentation. When you have spoken for 10 minutes, more or less, I will interrupt you to let you know that you have 10 minutes more. So the floor is yours.
So first, I'd like to start by thanking the organizers, Maria, also Michelle, for having us. And I'd like to just say a few words on what the talk is going to be about. So Maria and I work mostly on like, we are not philosophers of chemistry. We work on issues relating to philosophy of science, metaphysics, and me, I work in metaphysics and philosophy of science. She works in philosophy of science and philosophy of logic. And we have both a shared interest in philosophy of physics. And we have been developing these joint ideas on epistemology and metaphysics of science, involving ways in which structural realism might help us elucidate some notions relating to both the metaphysics and epistemology of science. So, so here's the key idea, right? So here's what we want to defend in this talk, right? So we want to defend that maybe there are some good reasons to be a structural realist about chemistry, and that those reasons are orthogonal to whether we should be a structural realist about physics itself. So that's more or less a general thesis, right? We want to explore that thesis. We don't have, we only have 20 minutes to explore it. But we should start out with some definitions, right? So I'm just going to very briefly and informally characterize the structural realist and scientific realist views. So on these views, on scientific realism, we usually believe, we usually take it for a fact that our best scientific theories, those that have been confirmed a number of times, that are successful as predictive tools, successful as ways for causally interacting with the world and so on, that those theories have some sort of grasp with reality. They connect with reality in some way, right? So the scientific realist thesis then will just be the thesis that the entities and structures posited by those theories are broadly correct, the more confirmation the theory has acquired, right? So obviously, I mean, there's this intuition that scientific realism is meant to be a thesis about a mind-independent reality. So we are going to have mind independence and realism about the ontology of our best scientific theories, and realism about the structures posited by our best scientific theories, right? So again, as a number of authors have pointed out since Loudon and Silos and so on, there are a number of issues with scientific realism. And so it comes that a number of philosophers of science have defended a version of realism which is weaker, which is called structural realism, right? So very broadly speaking, the structural realist thesis is just a thesis that we should be committed to the structures and relations, maybe posited by our best scientific theories in the sense just discussed previously, but that perhaps we should not accept a strong commitment to the ontology of our best scientific theories. And obviously, again, these are just very broad characterizations. So there are a number of ways in which you might refine versions of scientific realism or of a structural realism. Let me just mention very briefly a couple of ways in which structural realists have developed their thesis. So on the one hand, we have what is called epistemic structural realism, which is the view that we really just, our commitment is just an epistemic commitment, that what we know about scientific theories is just their structural properties rather than their ontology. So that's the epistemic view. So the epistemic view makes no claim about the status of the entities, whether there are actually entities or whether they are just like structures all the way down. It's a weaker thesis. And the ontic structural realist thesis, which again there are a number of versions of, is committed to the stronger thesis that the ontology of our best scientific theories is structures and relations all the way down, right? You know, and a number of authors have defended these views, you know, French Ladyman and so on, right? So here we just want to focus on the epistemic structural realist side. We're just going to be making some claims about mostly epistemic claims, but we will say something about the ontic aspect in what follows. But that's just, you know, broadly to get started the characterizations of scientific realism that we are going to be, and structural realism that we're going to be using, right? So again, one main motivation for adopting a structural realist view is that it seems to reconcile two tendencies in the philosophy of science, right? On the one hand, we have pessimistic meta-induction, which sort of pushes, you know, sort of defends the line that since past scientific theories have been shown to be false by observations, then perhaps we should not be committed to them realistically. That's that's like a pressure that the scientific realist faces. And on the other hand, you still have to explain the success of science, right? Like the no miracles argument. So the structural realist tries to make the best of both worlds by weakening the thesis, but still keeping retaining something, the structure in this case, right? So, okay, so here's a question that you might ask yourselves, right? So, suppose you are not clear on where you should be on the reductionist debate, right? Is it the case that maybe it's physics all the way down and everything else supervenes on the physics? So suppose you don't have a view on that, right? There are authors who have defended a more robust view on ontic levels and levels of properties. So, for example, according to some authors, for example, you know, in the philosophy of science and metaphysics, Ross and Schaffer and others, we might take we might think that we have fundamental properties maybe at the level of physics, but we also have fundamental or quasi-fundamental properties at the biological level, at the chemical level, and so on, right? This is a ledger account of reality, right? Of the structure of the world, right? And then people invoke things like emergence and so on. And then obviously there's the more sparse model on which all you have is just the physics and everything supervenes on the physics, like the, you know, the Humean supervenience views and so on. So suppose that you don't want to take a stance on that debate about whether, you know, everything reduces to the physics or whether there are like different levels of reality at the fundamental level, right? Then you might wonder whether we should be structural realists about physics and scientific realists about chemistry. Obviously we are broadly assuming a realistic framework, so no anti-realism we're not considering anti-realistic views here. So you might consider the following four possibilities: a structural realism about physics and about chemistry, a structural realism about physics but not about chemistry. You might be a scientific realism about chemistry, scientific realism about physics and a structural realism about chemistry, and scientific realism about both chemistry and physics, right? You know, again, the reason for not wanting to claim that you must be either both a scientific realist about physics and chemistry or a structural realist about both physics and chemistry. The reason for claiming that is just that you want to you don't want to commit to the fact that maybe the world doesn't have like a ledger structure, right? So take the view according to which you might be a structural realist about physics, but a scientific realist about chemistry, right? So that's like a sort of a strange view to consider. Most people, you know, in the philosophy of science have usually defended the view that we should be structural realists, especially about, you know, the higher level sciences, and then maybe, you know, perhaps the fundamental ontology will be at the physical level. But here are some considerations in favor of that view, right? Advanced by Karl Heffer, right? So Heffer has this paper on scientific realism and quantum theory. And one of the interesting arguments he gives in that paper is that If you consider only the higher level sciences, physics, biology, and a lot of the models and inferences that we have at those levels, then material science and so on, then those are pretty reliable sciences. Those models have a lot of confirmation evidence in their favor and so on. And everyone is agreed about the basic features of the ontology. So it might be the case, for example, that people disagree about the nature of the bonds between, what are bonds between chemical elements. It might be that there's disagreement about the specific ontic nature of those. But there's like the structural model of chemical bonds is very reliable, for example, right? And the classical model of molecules and so on are very reliable. They have a lot of confirmation. So it seems that we have like a very good grasp at the level of inference and at the level of what sort of functional role is there for the ontology of chemistry, right? And then the functional role here, like what sort of things are these, chemical objects, and what roles they play and how they enter into inferences and models. We have a very good grasp of that, right? So, and the functional role is basically very simple, basically equivalent to the structural role, to the structural realist role.
Excuse
I see you. I see you.
Moisés, you have 10 minutes more.
Yeah. So, so again, the structural role is just, you can see it as the functional role, right? Like what's the specific role that these entities play, right? So it seems that according to Heffer, that gives us reason to be committed to scientific realism about chemistry, but we should not be committed, according to him, to scientific realism about quantum mechanics, right? Or the fundamental physical level, right? And, the reasons have been discussed in this conference and are well known. We have the measurement problem. We have, the standard quantum mechanics is a theory which, because of the measurement problem, is in need of an interpretation, at least according to an important philosophical tradition. And there are a number of theories which are not equivalent to quantum mechanics, but which save, like a good structural chunk of quantum mechanics, such as many worlds, GRW, Bohmian mechanics. These different theories have different dynamical equations, different conditions for whether the world evolves deterministically or not, and different ontologies, right? So they are very different. They are different theories. They are not exactly quantum mechanics. They posit a different ontology and different dynamical equations, right? So Heffer thinks that that's a reason not to be committed to realism about quantum mechanics. Now, Maria and I are sympathetic with the idea that structural realism might be true about physics, and with some caveats, of course, which maybe I'll mention in a second, but we are on the fence about chemistry, right? Perhaps because of the argument that Heffer gave, right? That this, that at the level of chemistry, at least, and at the level of higher level sciences, there's a lot of reliability, agreement on models, agreement on entities, and so on. Even though there might be specific disagreements about like what are the entities grounding those structures. But I think that this is the main difference between Maria and myself and Heffer, right? So we believe that given that there are very different fundamental theories in quantum mechanics, there's this, and these theories are mutually incompatible, then whichever one of those turns out to be true is going to actually give us a different ontology of chemical objects, right? Like the underlying ontology is going to be different, right? But it's obviously the case that, for example, for the most important features that I just mentioned, the chemical bonds case, but for the most important features for the application of chemistry, all of those quantum mechanical theories are going to have to agree that there's something there grounding, these bonds. There's either the ontology of GRW, something about mass density is going to be grounding, connecting the atoms, or something about the spatial-temporal structure, the topology of spatial-temporal structure that arises out of quantum mechanics and the and entanglement and decoherence. All of these elements, entanglement, decoherence, non-locality, all of those elements are precisely versions of quantum mechanics, right? And all are crucial to a final understanding of chemistry. But the functional role of chemical ontology is safeguarded. However, that functional role is not specifically about entities. It's still a structural role. And we think that this has an important upshot for the epistemology of chemistry, as well as the metaphysics of chemistry. And Maria is going to talk to you about that. Sorry if I've taken too long with my part, but it's just, the fact that I had to move from the other computer where I had my handout to here.
Hi again. So with concerns to the epistemological part, you might say, well, it doesn't really matter if you have established that you have to be a realist about chemistry, so it doesn't really matter which type of realist you are going to be. However, we think that if we pay attention to these debates that relate physics, quantum physics to quantum chemistry, for instance, where you have still the open questions about ontology, you have to understand the theory or the framework as being defective. What defective means is a very broad general idea of having information that is not easy to reason with. So when you have defective information, that means that you have a case either of partial, vague, conflicting, inconsistent, or false information. And in those cases in which you have very broad and important open questions concerning the ontology, you are going to be dealing with a sort of defective information, either vagueness, conflicting interpretations of what the ontology is, and so on and so forth. And so what is the problem with that? The problem with that is that in cases in which you don't have a clear basis for your knowledge, you are going to undermine the realist commitments, at least from the epistemological side of what realism is, right? So in those cases, something that is going to be saving the day is the identification of certain parts of the structure of the theory or the model or the entities that you are talking about. And that is the reason why structural realism will help us to not only justify the realist commitments, but also deal with how we use defective information, not only in physics, but also in chemistry, where you might not have clarity about the entities that you are talking about, or the ways in which they relate to the entities of other layers of reality, such as physics, and so on and so forth. And which is the epistemic outcome that we can get. And so for epistemologists of science, there is a very, in a sense, new hot topic concerning scientific understanding, because they discover that understanding seems to be like the ultimate epistemic goal of science. And understanding needs us to have knowledge, a certain type of knowledge, and then to have extra things in order to see all our bits of knowledge together and get a better and more comprehensive picture of the world. In cases in which we don't have clarity about our ontology or the elements that we are talking about, or what the processes that the theories and the models suggest or mean, in those cases, you might have to renounce the idea of having understanding in science, or in those disciplines, or using those models, or using those theories. But that sounds very weird. If we are talking about quantum physics or quantum chemistry, we don't want to say that we don't get any understanding of the theory or of the empirical domain that we are talking about. So the reason why we chose to incorporate this into a framework of structural realism is that understanding is an inferential type of process. We identify certain patterns that connect our bits of knowledge or that justify certain chains of inference, and then we say, oh, that is what justifies my idea of having understood something. And so in the case of structural realism, that's exactly what you are doing. You are identifying structural patterns that allow you to put things together, right? And it doesn't really matter whether you know if these ontologies that you are positing correspond one-to-one to the actual world or the actual domain that you are talking about, or whether the interpretation is adequate, considering the actual world. But what that means when you are identifying structures is that you are able to determine a logical space in which you can navigate and interpret your models, your theories, or your particular domains that you are trying to explain. So it, in a sense, relates to this weaker sense of explanation that Mauricio was talking about. And that is the type of explanations that you are going to get from an structuralist realist perspective. And that said, the general upshot is that in cases in which you have defective information, you are going to be unable to justify the achievement of understanding. And that is what undermines the also rational commitment to scientific realism. So if you are able to identify certain privileged inferential patterns or certain privileged structures in your discipline, then it seems not only that you are going to be able to justify that you have a certain type of realist commitments, which are going to be a structuralist, but also you are going to set the grounds for achieving and explaining your feeling of having understanding, legitimate understanding in that discipline. And I think that's it. Thank you very much. Moisés, do you want to say something final? Yeah, he's coming back. Run. Yeah, but do you want to say something?
No.
No?
I think that just, I guess, to round up the talk, we believe that it's worthwhile to explore the possibility that regardless of whether we should be realists about fundamental physics or not, scientific realist, there might be good reasons for being a structural realist about chemistry. That's like the metaphysical part. And then we believe that that is going to help with the epistemic project of understanding and inference in the epistemology of science on the epistemic side. Yeah, so thank you.
Thank you, Maria and Moisés. We can start a round of questions and answers. So we have a few minutes for this. So please be brief and concise with your participations. Anybody has a question? Okay, Keith Tabor, please.
I just wanted to say something about understanding, because I wanted to check that my take on understanding was the same as yours, that understanding doesn't necessarily mean understanding correctly, and understanding is not binary, that people have degrees of understanding. Some people understand in greater depth, greater sophistication than others. And I would assume you thought the same, but I just wasn't quite sure from the way you spoke about understanding.
Yes, so one of the main features of understanding is gradability, as you are mentioning. So, but ideally, gradability can only go up from the level in which you are starting your understanding. So if you go lower, then that means that you had the illusion of having understood. If you say, I understand this, and suddenly you get an information update and you realize that the quality of your understanding was not as high as you imagined, then that only gives you evidence in favor of having not understood, that you were misinterpreting the feeling of grasping and the sensation of having gotten a better picture of the domain or the theory and so on and so forth. So, and that relates to the idea of how correctness or soundness is involved with understanding. So the main upshot is that there are many debates regarding whether everything that you put in the content of your understanding has to be true or not. But it is well said that it has to be extremely reliable, and that it has to correspond in the physical or empirical disciplines. It has to correspond to the domain that you are talking about in a very strong way. So you might use certain elements that are not real, or for instance, logical tools or mathematical tools, and you might commit to them to be necessary for your understanding, but that doesn't mean that they are part of what you understood. And so the general claim about understanding is that it has to be very correct, very stable through time, and to after information updates and so on and so. That is the reason why in cases in which you have defective information or you have vagueness, it's not very clear that if you add more information, you are going to be able to preserve what you think you understood. And that will only fit the idea that it was just a mistake, an illusion of you, on your side.
Okay, I mean, I think you've introduced another variable there, which is the kind of making sense, the internal subjective feeling of understanding. But of course, your model seems to assume that there is a canonical understanding which is known, and that someone is able to make a judgment, yes, that person understands correctly, that person has a misunderstanding, which for somebody working in education, I don't think is always quite as simple as that. But I think you've got perhaps the complexity of understanding, the canonicity, if that's the right word, of understanding, and also maybe the subjective experience of how well somebody feels they understand something. And they can be three separate things.
Yeah, you're absolutely right. So understanding is often characterized by the balance between a subjective and objective element, because you want to avoid the cases in which you have the subjective perspective of the agent, in which he or she feels that she has understood something, but they are illegitimate cases, such as the ones in conspiracy theories. So you need to add the objectivity element, which in the cases of scientific understanding might come from the domain or might come from the theory itself. But that is the reason why we wanted to connect it with scientific realism, because we wanted to say that there is a reason to accept that when you have this type of understanding, there is a correspondence in the domain, even if it's not as strong, like one-to-one correspondence, there is something there that legitimates the understanding. Do you want to say something?
Right. So basically the idea that you can preserve truth in understanding if you weaken it to the structure, not necessarily keep the ontology, right? So that's sort of like the idea here.
Yep.
Yeah.
Can I just say one more thing, which is, I'd be interested to see how you relate that to a historical case study. So if somebody had a very good understanding of chemistry in terms of phlogiston or in terms of the four traditional elements, then by current conventional view, we would say they didn't have a very good understanding, but they may have a very sophisticated, integrated, complex and highly applicable understanding in another sense. Just something maybe useful to consider, maybe not.
No, absolutely. So again, like the reason we chose structural realism was because one of the motivations for the view is that it's supposedly able to respond to the objection, to those types of objections. So the idea will be that, for example, just take a case from physics, right? So for example, if you have Newtonian space-time, you might think that you understand what that space-time is like. It's Euclidean and it has like a real time and so on, right? But then comes relativity, right? And then it seems like, did you understood like space-time at all on the Newtonian view? So according to the structural realist, yes, you did understand, because you take the space-time case as a limiting case of special relativity on like local conditions. So you can say that there are two elements that are preserved, that there are elements that are lost in science, and there are elements that are preserved. And then part of the structural claim is that the elements that are preserved as a structure, as structures that are retained in the successor theories, right? It's not exactly the same ontology, so you don't have phlogiston anymore, but you have whatever inferential role phlogiston was playing, you get something in return for that. Yeah.
Thank you.
Thank you very much.
We are on time, so the last question is for Michelle, please.
It was just a quick question about defective information. So you mentioned contradictions and when there's vagueness, but we heard of another type of because you said part of the problem with defective information is that it's very difficult to reason with it, right? That you have difficulties. And what we heard about earlier, even today, was the notion of sometimes the calculations are so complex that it's just, as scientists, we find it very difficult to have that feeling of understanding satisfaction. So phenomenologically, it's tricky. Now, I don't know if again, because this speaks to how you were answering Keith's question, how much the phenomenological part of understanding is at play with your notion of defective information.
You want to say something?
Yeah, I mean, I guess maybe the way we will respond to those types of problems will be to distinguish specific elements in understanding from more general elements. So, for example, you can say it's obviously the case that physics is a highly idealized science, right? And so are the rest of the sciences, right? So we have these models and we use them in different cases to investigate phenomena. But obviously, you know, that like there's no scientist can, you know, perform all the calculations or even, you know, be extremely accurate about many of the inferences and deductions and so on. But we can say that, for example, the mathematical structures that underlie some of our best performing models, for example, in this case, what is classically called the structural model of the bonds, for example, which is, you know, a classical model, as well as in many other cases of scientific practice. Many of those structural elements can be understood in a general manner, right? And we know that they are reliable because they give way to applications and manipulations and predictions and so on, even if there are many details that we cannot understand precisely. So you can say that the level of subjectivity of understanding really is stronger with regards to the mathematical structures or models or representations that we use that are extremely successful, for example.
Okay, so
Thank you, Michelle.
thanks, Maria. Thanks, Moisés, and for the participants. Now